Hey guys, welcome to Tool of the Week. This week we're going to take a look at GDB, which is a command line debugger. So the prereqs for this tutorial, you need to be a developer who has used a debugger before. Now that could be a GUI or a command line debugger, it doesn't matter. You just have to have used a debugger before, so therefore you're familiar with common debugging terminology and concepts like what does it mean to attach to a process? What's a breakpoint? Things like that. Let's quickly go through what we'll cover in this video. We'll show you a few different ways that you can launch GDB, how you can control the execution of the process that's being debugged, how you can view source code as you're debugging, how you can view variables as you're debugging, including examining the call stack, so how you got to where you got. We're going to take a look at breakpoints, how to set them, how to remove them, conditional breakpoints, which by the way are breakpoints that will trigger only if a certain condition is true. We're also going to look at how you can automatically do stuff, so execute commands when a breakpoint has been triggered. And we'll cover catch points. So a breakpoint is placed somewhere on your source code, right? And what a breakpoint says is when the CPU starts executing a particular line of code, trigger it. A catch point is triggered when a certain event occurs to your process. So for example, when your process receives a particular signal, when your process throws a particular exception, when your process catches a particular exception, when your process loads a particular library, things like that. They're very useful. We're also going to look at how you can automate a large portion of your debugging workflow. So how you can automatically launch GDB, have it launch your process, passing it some arguments, set it breakpoints on it, and then like basically automate as much of your debugging workflow as possible. We're going to cover convenience variables. So GDB, while you're debugging, you can create variables and you can use those variables throughout your debugging experience. Control flow statements, you can write GDB in little scripts, basically little scripts that control GDB. And those scripts can have control flow statements like if and while. We're going to look at how you can execute any shell command, any arbitrary shell command via GDB. And then we'll kind of put all of this together, all these really cool features, we'll put them all together and show you how to use all of it to automate a large portion of your debugging workflow. Okay, so what I have here is my desktop, and in this folder I have an executable that I created, and we're just going to use this as an example executable to debug. So let me just launch the executable to show you. Alright, we're going to launch it in the background. Here it is. It's just a window with a button that says what time is it. When you click the button, it just says hello world, and then it shows you the time. Every time you click the button, it updates the time. I just built this quickly using Qt, just so we can have an example executable to debug. Let's exit it. Now there's quite a few ways that you can launch GDB. The most straightforward is attaching it to a process that already exists. So let's go ahead and launch our executable again. So create a process. All right, let's get the PID of this process. Here's the PID. Now copy that and then do GDB-P with the PID. This will launch GDB, and GDB will attach to the process with this process ID. And there we go. So you'll notice that GDB, when you launch to an existing process, as soon as GDB attaches to that process gets broken. And you can tell that by two ways. One, because you see the GDB prompt. And by the way, whenever you see the GDB prompt, you can start typing GDB commands. We'll go over GDB commands shortly. So the first way that you can tell the process is broken is that you see the GDB prompt. The other way, and this is obvious, is Watch, when I try to interact with the process, I'm clicking, nothing happens because it's broken. A quick note on terminology. Here, when I say that the process is broken or something is broken, I don't mean it's not working. What I mean is that it's been stopped by the debugger. Okay, so that's the first and probably the most straightforward way to launch GDB, and that is to attach it to an existing process. But you can also have GDB launch the process for you. Let me show you that next. To have GDB create the process, launch GDB with the executable name. So GDB and then the executable name like this. And then at the GDB prompt, as soon as you type run, then it will actually create a process from this executable file. One note, here after run, you can put in some arguments, right? And all these arguments will be launched to the executable before a process is created from that executable. But I don't really want any arguments to go to my process. But if you did, just put the arguments here. So you could put argument 1, argument 2, etc. And all of these arguments will be passed to your executable before a process is created from it. So let's run our executable with no arguments. So it's starting it, and there we go, it launched. Okay, now you'll notice that when you use the run command to have GDB launch your process, the process is not broken, right? I can interact with it, and I don't see the GDB prompt, so the process is not broken. If you want to break the process at any time, make sure that the GDB terminal, so the terminal that GDB is running in, is selected, and just press Ctrl+C. And that will break the application wherever it is. So right now I can't interact with it. And once the process is broken, then you can start executing GDB commands. So before we look at the third way to launch GDB, let's go ahead and see some example GDB commands. In other words, how do you typically use GDB? All right. So to continue so we know right now our process is broken, right? Whenever your process breaks, by default, you get a little message that tells you where it's broken. So right now we're broken in some function in poll.c. All right. Type the continue command to have GDB basically continue the execution of your process. And your process will continue to execute until it hits a breakpoint. So there we go. Again, if you want to break the process, select GDB terminal, press Ctrl+C. All right, so now we're broken. Let's say I want to set a breakpoint. Now, there's a function called onButtonClicked, a callback, that gets executed when this function is clicked. I want to put a breakpoint on onButtonClicked function. So, to get the full signature of a function, use this. So do info functions, and then put a regular expression that matches a part of the function name, right? And then you'll get the full signature of all functions that match. Let me show you by example. So we want all functions that match on button clicked, and it found just one function, right? And here it gave me the full signature. So I'm going to take the signature right after the return. I'm going to take the full one, copy it, and then I'm going to use the break command to put a breakpoint on that function. You'll notice it says breakpoint 1 has been set. Now to see all the breakpoints that I've already placed, I can use info breakpoints. You'll notice that each breakpoint has a number, and you'll notice that each breakpoint can either be enabled, Y means yes, and N means not enabled, so in other words disabled. And it also tells you where in the source code that breakpoint is at. Alright, let's continue the execution of our process. Let's go ahead and click this button and see if our breakpoint triggers. And it does. So we see the GDB terminal. We notice that we are broken, and the place that we're broken at is on button clicked. Okay, now oftentimes as you're stepping through the execution of your program, you want to see the source file. So the easiest way to do that is to go into what's known as TUI mode or TUI mode. TUI stands for Text User Interface, and that basically makes GDB terminal look a little bit different. So let's enter TUI mode, and you enter TUI mode by typing layout next, and here we go. So you'll notice a little highlighted line as well as this arrow that shows you where you're currently broken. So we're broken right at the top of the on button clicked function. To step to the next line, do next. So that executed code until we reached the next line. To also execute this highlighted line, type next. So you notice that as I type next, I'm executing one line at a time. To look at the value of some variables, so you notice that we have a variable A and B, just use the print command. So print A shows us 3, and print B shows us 10. All right, so let's do next to step down again, and we'll do next to step down again, and even next one more time. Okay, so if we do next again, then it will just go to the bottom of this function because that's the last statement. But what we really want, I want to show you a different execution control command. I want to go inside this setText method, right? I want to go in it. So to go in as opposed to past, you use step. So step means step into the highlighted, the function on the highlighted line. So we step into it, and we're in some Qt source. So it kind of looks like mumbo jumbo here for me. Now to finish executing this function that we've currently stepped into, just type in finish, and you notice that we come back up. So we finished, we jumped into setText, we executed all of it, and we came back out. Okay, so that's how you kind of step through your program while you're looking at the source code. That's called TUI mode, right? All right. So to get out of TUI mode back into that regular GDB terminal, just type in TUI disable, and here we are. I want to give you a quick tip right now before we move on. You know that whenever you see this prompt, right? This is the GDB prompt, not your regular terminal prompt. So right now, you're only allowed to pass in GDB commands. But if you put an exclamation mark right here, now you can pass in any shell command, and that GDB will just execute that command using the shell. So we can do clear to clear the screen. Okay, so now I want to go back. So now that we've done a little bit of stepping through, looking at the source, a little bit of execution control, I want to show you the third way to launch GDB. And this third way is really, really good for when you're looking to really automate your debugging workflow. So first, let's see, how should I explain this? Okay, so I'll show you the command. Let's get out of GDB. So to get out of GDB, just do quit, Y to confirm, okay. Launch GDB like this. So do GDB batch -x, and then here you want to put in your command file, and I'll explain these in a little. And then you do --args and put in your exe file, executable file. Okay, so this is what the syntax looks like. Now what this tells GDB is to create a process from this executable, right? So that's the executable that it will create a process from when you call run. Okay, remember that. So when GDB executes the run command, it will create a process from this executable file. And this part of the command tells GDB that, hey, don't look at the console, don't look at the terminal for commands, read GDB commands from this file. So you're saying here's the executable and here's the GDB commands. In other words, don't try to get the GDB commands from the terminal, just get them from this file. So you can see how that automates a lot of what you do. So let's go ahead and do an example, all right? So we will leave, let's see. All right, well, we're going to get rid of that. We will create a new file in the same directory with our commands. So I'm just going to call it commands. There it is. I'm going to open that out. Okay, I got my command file. Now let's put commands that GDB should execute, right? Instead of in the terminal, we put them in this file. So let's say we just want to print, for now we just want to print hello. So now you've also learned about a new GDB command called print. And this does exactly what it sounds like, it just prints. So we want to print hello. And let's say that's all we want to do. So we want to save our, actually we want to print hello and then we want to call run. Because remember that GDB will not create a process from the executable until you call the run command. And also remember that you can pass in arguments here. And all these arguments will be passed to the executable before it's launched. All right? Okay, so in our GDB commands, we're just going to print hello and then we're going to run the executable. So we're going to save this and then let's go ahead and launch it. So we'll do GDB batch. All right, so here is the name of your commands file, right? The file that contains commands that GDB should start executing, and here's the executable. Let's go ahead and run it. And you notice immediately that it prints hello because we told it to, right? The first thing it does is print hello, and then it runs the executable, so it creates a process. And we can see that it did that too, right over here. Okay, so we've learned a couple things. We've learned a few different ways to launch GDB, how you can view the source while stepping through the code, so execution control. You learned about the print command and a few other things. Don't try to remember all of these because I'll provide some notes in the description of the video. So you'll receive a textual tutorial and you also get a little reference of everything that we've learned. So just try to, you don't have to memorize anything, just try to understand. All right, I want to show you a couple of different ways to view source. So I showed you the TUI mode. Let me show you a different way. So first, let me go ahead and exit this. We're going to press Control C. All right. And now let's go ahead and just launch GDB with our example project. We're going to run it. Okay. Now Control C to break. Info functions on button pressed. So I want to find the signature for all functions that have this regular expression in their name. Oh, on button pressed. I think I did on button clicked. Yep. So here's the signature. I want to put a breakpoint on that. I do info breakpoints. Okay, I've put that breakpoint in the proper place. And now we're going to do continue. All right, so that's continues running our process. Now we're going to click the button and we break. Okay, so you know the usual drill. You can do layout next, enter TUI mode, and then step and look at the source code. But now I want to show you a different way to look at the source code. Let's clear the screen. So as soon as you are broken, you can type in list to view 10 lines of source around the area that you're broken. So we are broken on this function, as you know, and it's showing us 5 below, 5 above, roughly. Now, if you type in list again, it's gonna, in the same file, so in the same file as here, it's gonna move down 10 lines. Okay? But if you wanna move back up, you do list minus. And in the same file, it'll move back up 10 lines. So how does this work? When you initially break, the first time that you do type list after you break, it's gonna show you the source code around where you're broken. Subsequent lists and list minus commands will move you down or up relative to where you are currently. I hope that makes sense. Okay, let's clear the screen. Now, if you want to view the source code for a particular function, so let's say I want to view the source code for the on button clicked, you can do list and then the name of the function. So there, that will list me the source code for that function. And again, I can move up or down this same file by doing list to move down, list minus to move up. All right, so I showed you how to search all functions by doing info functions and then a regular expression, right? You can do a similar thing with variables. Just replace this part with variables. So this will show you the full signature for all variables whose name matches this regular expression. All right, now let's go into more detail about how you can view variables when you're debugging, right? So right now let's go ahead and continue first. So we're going to let our process run. We're going to press this to trigger our breakpoint. We're going to do list to see where we're broken, and we're broken right here on button clicked, which makes sense. You know you can use the print command to view the value of any variable, but you can also view your call stack, right? So how did you arrive to this function? You can do that by doing backtrace. And one thing I should notice is you'll notice that our call stack right now is very big, right? And whenever GDB outputs in the console a lot of text, you'll get this little message that says type return to continue. So type return to continue seeing more text, or Q to quit. I don't like the fact that it does that. I want it to just show me all the text. So let me just Q to quit, and then to turn that thing off, we'll do set pagination off. Now GDB will show you all the text. It won't ask you to press enter to view more. All right, so once again, let's view all the call stack by using the backtrace command. Okay, there's our giant call stack. Sometimes you're only interested in viewing the top couple of frames. You don't want to view the whole thing. So we'll do backtrace, let's say 5. That shows me the top 5 frames. Now, of course, you know that a frame is just a particular function in your call stack. And GDB also has the concept of selected frame, okay? Because certain other commands operate on the selected frame, and I'll show you that in a little bit. By default, when you break, the selected frame is the frame on the very top of your function of your call stack, which makes sense. So, what commands operate on the selected frame? Well, first of all, the info args. Info args will print to you all the arguments that were passed to the selected frame. So, our top frame has 2 arguments, and here it tells us the name and the value of those arguments. You can do info locals to view the local variables in the selected frame. If you want to change the selected frame, just do frame and then type the number of the frame that you want to change to. So here we want to go to the 3rd. Okay, let's clear and do info. Let's view the arguments that were passed to this frame. Let's view the local variables that were passed to this frame. No locals. All right. So clear the screen. You can also use the up and down commands to go up 1 frame or down 1 frame. So right now we're on frame 3. If I do down, now I'm on frame 4, and it tells me, or I can go up to go up 1 frame. So up and down. And that's another way to change what frame is your selected one. Okay, so we gotta learn a little bit more about breakpoints. So let's clear the screen. So you know about info breakpoints, and you know how to break at a particular function. Let me show you how to break at a particular line. So to review, to break in a particular function, you know you can do break and then the function name, right? To break at a particular line, the syntax is like this: break, and then do file, colon, and then line number. All right, think that's simple enough? I don't have to show you. And again, don't worry, don't frantically write the syntax down. I'll have all of it in a little reference sheet for you that you can find in the description of the video. All right, so let's see some operations that we can do in our breakpoints. So we do info breakpoints, and here we have a summary of all the breakpoints that we've placed. We've only placed 1. So it gave the number 1 to this breakpoint. Every breakpoint has a unique number. The first one that you set starts with number 1. The second one that you set goes to number 2, and so on. Okay, this also tells you that this breakpoint is enabled. If you disable it, it will not be triggered, basically. But it will still show up when you do info breakpoints. So enabling and disabling is a quick, fast way of exactly that, enabling and disabling a breakpoint. So you don't have to place it again. And it also shows you where in the source code this breakpoint was at. Let's disable this breakpoint, so we'll do disable breakpoint number 1. Now we'll do info breakpoints, and we'll notice that enable is no, so it's disabled. Let's enable it again, info breakpoints, and we notice that now it's enabled. All right, so if you want to completely delete it, then you can do delete and then the breakpoint number, but I don't want to do that. Okay, so you can put conditions on breakpoints, which means only trigger the breakpoint if a certain condition is true. The syntax for that is like so. Do condition and then put in the breakpoint number and then the condition. All right, in order to show you a demonstration of conditional breakpoints, let me introduce to you another really cool GDB concept called convenience variables. Okay, so remember GDB can create its own variables, and here's how you do that. Let's create a variable, do set myVar, and we're gonna give it 3. Variables can be assigned any valid C++ expression. Okay, so 3 here. All right, and to print your convenience variable, just do it like this. It's just like printing a regular C++ variable. A convenience variable, it just starts with the $sign. Okay, that's all. Okay, so now you know how to set convenience variables and how to print them. Let's show you a conditional breakpoint. All right, so we're gonna add a condition to breakpoint number 1, and we want that condition to be that my var is equal to, we'll say 5. Okay, so if my var is equal to 5, then breakpoint number 1 will be triggered. My var is 3 right now, so that condition is not fulfilled. Let's continue and let's see if that breakpoint gets triggered. Nope, it does not get triggered. Let's Control C. Let's clear the screen. Info breakpoints. All right. So you'll notice that when I put a condition on my breakpoint, it shows you that in the info breakpoints, region. It says that stop only if, and it tells you that this breakpoint will only break if my var is equal to 5. So let's go ahead and make my var equal to 5. So we'll do set my var is equal to 5 now. Let's verify. Okay, now we're going to continue and we're going to see if the breakpoint triggers. Yep, it does. So let's remove that condition. To remove a condition from a breakpoint, just do condition and then the breakpoint number, and just don't put in a condition. That's it. And it even tells you breakpoint 1 now unconditional. And furthermore, if we do info breakpoints, we'll notice that it doesn't have a condition here. And it did before, see? Okay. All right. In addition to having conditional breakpoints, you can have breakpoints that will automatically execute some code when they're triggered. So the syntax for that is you do, well, let me show you via an example. So let's do something whenever our breakpoint is hit. So do commands and then the breakpoint number. So we want to specify some commands that will be executed when breakpoint number 1 is triggered. Press enter, and now you start typing in your commands. So I'm going to say print hello, like that, print hey. Okay, that's all we want to do. Once you're done with your commands, just type end. All right, and let's do info breakpoints, and you'll notice that for our breakpoint, it tells you that when it's hit, it will execute these 2 commands, right? So let's go ahead and continue. Let's trigger the breakpoint. You notice that it printed out the things that we told it. All right, you'll also notice that in addition to executing the commands that we specified, it printed out this message that tells you, basically the location of the breakpoint that was just triggered. If you want to suppress that message, just add a silent command above. So let me show you that. We'll do commands for breakpoint number 1. For silent, this means suppress the default printed message, and then we just want to print yo, and that's it. So let's go ahead and trigger it, and you notice that now we truly only executed our commands. Okay, so we learned a lot of really neat stuff so far. So you learned how to launch GDB, including how to launch it in a very automated way. You learned how to execution control, how to make your process break, how to make it continue, how to make it step, how to view variables and source as you're stepping, how to specify conditional breakpoints, how to specify commands that will automatically be executed when a breakpoint is hit. You learn about command files. A lot of, with what you've learned so far, I would say you're pretty competent in using GDB. But let's go ahead and continue to learn about more of its really useful features. So related to breakpoint are catch points. So catch points are triggered not when the CPU is executing a particular line of code, but it's triggered when a particular event happens to your process. So for example, when your process receives a particular signal, when your process throws a particular exception, when your process loads a particular library, when your process unloads a particular shared library. Basically events, right? Let's go and let me show you some examples. Once I show you a couple of examples, you'll get the point. All right, so let's say we want to specify a catch point that triggers when your process throws a particular exception. Here's how you do it. So first of all, let's clear the screen, do enfold breakpoints, and we notice that we have one breakpoint on this function. All right, now let's put a catch point. Do catch, and then throw, and then regex. What this says is I want to create a catch point that will be triggered when my process throws an exception whose name matches this regular expression. If you leave out the regular expression, then this catch point will be triggered when your process throws any exception, okay? Notice that the syntax that I'm using, the square brackets for options, square brackets means that it's an optional argument. That's basically the syntax that everybody uses when they specify optional arguments. So regular expression here is optional. When you leave it out, the catch point will be triggered when your process throws any regular expression, okay? So again, don't worry about the syntax, just make sure you understand what's going on because I'll have a reference for you. All right, what if you want to stop your process when it catches a particular exception? Well, you do catch. That's not a typo, that's catch twice, and then regex. The regex should be the name of the exception that you're interested in, again. What if you want your process to break when it receives a particular signal? You do catch, signal, and then put in the signal name, right? For example, sig term, okay? So when your process receives the sig term signal, then it will be broken. Let me show you this one. Okay, so info breakpoints. Notice that info breakpoints shows you your breakpoints and it shows you your catch point. So number 2 is a catch point. It's enabled, so you can enable and disable catch points as well. And this catch point will be triggered when your process receives the signal sig term. Let's give our process sig term, okay? So let's continue it. And let me open up a new terminal here. And I'm going to use kill. Well, let me get the process ID. And let's send sig term to our process, right? And then let's watch and see if our catch point will be triggered. There you go. Our catch point got triggered. Okay, we don't need this anymore. All right, a couple more useful catch points. So if you want your process to break when it loads a particular library, you can do catch load and then a regular expression. And of course, I mean a shared library here. So again, if you leave the regular expression out, then your process will break when any library gets loaded. There's a similar one for the unloading of a particular library, okay? So it looks like that. And then another useful one is if you want your process to break when it receives any signal. So you can do catch signal all. Okay, the next thing I want to cover is logging. So you notice all the output text that GDB spits out, right? For example, when a breakpoint is hit, it spits out some stuff. When you do print, some stuff gets spit out. So if you want to keep a log of all of that, GDB can write to a log file in addition to writing to the console, right? So how do you have GDB spit out to a log file, spit everything out to a log file? You just do set logging on. You'll notice that as soon as I do set logging on, in the current working directory of GDB, which right now is this directory, it's going to create a file called gdb.txt, and that's the log file. That's the file that GDB will spit its output in. Let's go ahead and run it. You'll notice that we created a gdb.txt right here. And now when we do print, let's print, let's see, water. I don't know, I'm not very creative. So print water, and you'll notice, yeah, that goes to our output here, but it will also go to the log file. And let me prove that to you. I'm sure you don't believe me. There you go. So now let's print something else. Print as da. There you go, again. Okay, so we've learned quite a lot about GDB. Now to tie all of this together, let's say I want to do some pretty complex debugging and I want to automate it all. So what I want to do, here's my plan. I want to launch my executable, so I want to create a process. I want to set a breakpoint on the callback, so the on button clicked function. Then I want to count how many times that button gets clicked. And then if it gets clicked more than 5 times, what I want to do is maybe write a message to the log file, something like, I was clicked 5 times, and I want to quit debugging automatically. So how do I do all of that? We can put all of that in a command file, and then we can launch GDB using that third method of launching that I talked about near the beginning of this video, to tell GDB, hey, start executing commands from this file. So let me go ahead and write the commands first, and then I'll talk about it to you. Okay, so I went ahead and wrote my command file. All right. So the very first thing I want to do is I want to turn on logging so that GDB will create that gdb.txt file. In other words, so that all of the output goes to the log file, right? Then I make a convenience variable called hit count, initialize it to 0, and then I put a breakpoint on the on button clicked function, and then I specify some commands that will be executed every time that on button clicked function is hit, right? So you'll notice that I say I want to specify commands to execute when breakpoint number 1 is hit. Well, this on button clicked will be breakpoint number 1, because remember, the first breakpoint that you placed is number 1, the second one that you placed is number 2, and so on. Okay, so I put some commands to automatically execute when on button clicked is hit. What do? I increment hit counter, and then I use an if statement. And this is something new, so pay particular attention here, because I haven't shown you the syntax for a hit an if statement, but it's pretty easy. You just start it with an if, and then you put a condition, and then you put statements, and then you put end. That's basically, and again, I'll have this in the reference in the description of the video. So I see if the hit count was greater than or equal to 5, then I print to the log file I was hit 5 times, and I quit debugging. I quit GDB. If the hit count is less than 5, I just continue. Because remember, here we have hit a breakpoint, so we must continue it so that GDB can continue to run. And once I have done all this, where I've specified my breakpoint and the commands attached to that breakpoint, then I say, okay, launch my process. So, okay, now let's go ahead, and if we do this, we're telling GDB to start executing commands from this command file and to create a process from this executable. So run that. Here it is. So let's click this once, twice, 3 times, 4 times. 5th time it exited, because that's what we told it to do. Let's look at gdb.txt, which is a log file, and you'll notice that right before it exited, it logged I was hit 5 times. Okay, and that's pretty much it for this video. I'm just showing you this because I'm going to have these slides, so I'll have the summary up in the description of the video. And this is just basically a reference. So the commands for launching, the commands for execution control, the commands for viewing source, the commands for viewing variables, as well as commands for managing breakpoints, commands for catch points, commands for convenience variables, control flow statements, so the syntax for an if and a while, executing arbitrary shell commands, and quitting. So I will have those slides up in the description of the video. That's it. So if there's any questions, go ahead and post. I'm pretty good about answering most questions. And very importantly, if there's any feedback for future tutorials or future videos in this series, give me some feedback so I can adjust according to that feedback. So did I go too fast, too slow, too much details, not enough details? Just let me know. And if this series actually interests you, you can subscribe, and apparently you have to click on a little bell icon. I don't really know because, to be honest with you, I don't subscribe to anything. I don't use really YouTube besides uploading, but apparently you have to click on the little bell icon too so that you're actually notified when I upload a new video in this series. That's, do that if you're actually interested in keeping up with videos in the Tool of the Week series. As always, thanks for watching, and bye-bye.